So, we get asked this question a lot of times that on a normal distribution, when you're looking to find probabilities, right? And say you've got a mean at 78 and there's a standard deviation of, say, 10. So on such a normal distribution, you're looking for a very specific region, and these form what's called a negative interval. So you're trying to find probability of this region right here. And this then corresponds to some x values, right? Which could probably be maybe 70 and say 60, right? So between 60 and 70, you've got this region, and this is the x-axis right here, and you've got this region, and that corresponds to a certain probability. This could be anything, wingspan, it could be distance, could be a lot of things. But the question here is, how do you solve for this specific region of interest? How do you find the probability here on a normal distribution? Now, this is fairly straightforward when we know the mean, standard deviation, and these values on Excel, right? So on Excel, this is quite simply the norm, the normal distribution. We know it's 70, the mean is 78, standard deviation is 10, and yes, this is cumulative, minus norm dist formula again, and we know this is 60, mean is 78, standard deviation is 10, and we hit true, and we get 0.1759, right? So this region is in fact 0.17, right? So we get this from Excel in a fairly straightforward way. But how do we obtain this region if we had to do this on, let's just say, using a z-table, right? So the way to do it, or the way to break this problem down really, is to identify our key regions of interest. So it would be a good idea to break this problem down into two cases, right? So first would simply be to set this up and recognize that this 70 corresponds to a region, right? I'm going to go ahead and shade this region and say, okay, anything less than 70 corresponds to uh, this entire region. Uh, and then something less than 60 corresponds to another region, right? So I could, in fact, go ahead and do something of this sort, right? I could say 60 is here, 78 is here. Notice this is still x, right? And I would shade this region. Now, recognize that this is in fact, the central region is in fact a difference of these two regions. So this bigger region, and you subtract the smaller region from it, and you will see that you in fact arrive at the same central region right here. There it is, right? If I extrapolate this here on this curve, so you see I extend the 70 line, and you subtract the smaller region from this big region, you come across this central region that we were interested in. So then the question really is, how do you find these regions? Because the z-table that we're also familiar with does not show up the negative values. So one thing that we could do is flip these regions, right? So because this is going to correspond to a negative z-value, and I could always obtain what my z-value is corresponding to 70, I could do z equals x minus mu over sigma, and that gives me 70 minus my standard deviation is 10, and my mean is 78. 70 minus 78 over 10. So this turns out to be minus 8 over 10, which is minus 0.8. Okay, so I know now that 70 corresponds to, and I'll draw the z curve here, and I know 70 corresponds to minus 0.8. On a standard normal, the mean is at 0. So that's something that I know right away. Similar thing I could do for this one, for this smaller region, right? So I could make another one here, and I would say, okay, this is z. What does 60 correspond to? Again, I would need to do x minus mu over sigma, and that would give me 60 minus 78 over 10, and that would be minus 18 over 10, which is minus 1.8. So I know this is minus 1.8, right? So I have negative 1.8 here, I have negative 0.8 here, and I need the central area. So now this is the interesting part, because if I know that this is my tail area, so to speak, what I could do is I could move this negative z value to a positive z value. Remember, why am I doing this? Because for me, positive z values are accessible. I don't have the negative z values on the z table, right? So I want to make sure I have a positive z value, and it's okay to flip them. That's fine. The tail area that I have here is the same tail area that I have here. It's just that you flipped the negative 0.8 to the side, and you arrive at the same area. And this is interesting and this is important for me, because now my z value is positive. The z table is going to give me values to the left hand side. That's the convention. And I'm okay with that, because as long as I have positive z values, I can always find areas on both sides of this line. So essentially what I would be looking at, I would be going to the z table, I would find the value corresponding to, I'm going to denote it with phi, and see what does 0.8 give me. It's going to give me some probability, it's going to give me some area, but that area is basically going to be to the left hand side of 0.8. It's going to be this area. It's going to be this entire blue area, right? So this is actually going to be my my blue area, right? So to the left hand side of 0.8. And I'm happy with this area, because I could always do 1 minus this blue area, so to speak, to arrive at what's really uh, the red area. Okay, because the total probability under the curve is 1. I subtract the blue area, I will get the red one. Okay, z table, positive z values, give me areas to the left. I have the area to the left, which is blue. I subtract that area from 1, I will get the area to the right, the red one. And once I have this area, I am super happy, because this area is the same tail area that I had here. So half of my work is done. Now I just got to repeat the same thing for this one. I'll go ahead and do it actually. So again, I'll do the same thing. I'll set this up on the z-scale. I'll draw my normal probability in my normal distribution. I would recognize that I had negative 1.8 here, right? Which corresponds to what? Which corresponds to this tail area, smaller tail area. And if I flip this negative 1.8, I could bring it here, right? So this could then become plus 1.8. I'm happy with the positive z value, because the z table lets me see positive values. And then I would set up the area of my interest, the tail area, right? And remember, I want this tail area, so when you make it plus 1.8, it corresponds to this exact same tail area. Now I'm happy, because I have a positive z value. I could always find the area to the right, and this is something I can do very easily by looking at the z value for 1.8 at this time, and this is going to give me, again, this blue area, because the z table always gives you area to the left hand side. Okay, so one more time, when I look at the probability on the z table for 1.8, it's going to give me area, this blue area to the left hand side of positive 1.8. I subtract this area from 1 to arrive at the area on the right hand side, which is my red area. Okay, so let's just actually call them red A, and let's just call this red B, just to make a differentiation. Let's call this A, call this B. Okay. Similarly, if that's A, and this is also A, because it's the same tail, just on the other side. This is B. It's the same tail, just on the other side. So now I have got these two areas, red A and red B areas. Notice I've got them here, but these are the same ones on the other side of the tail, such as here. And the only thing left now is to subtract this smaller area from this bigger area to arrive at the central area. So I'll go ahead and do that. Whatever those numbers are from my z table, and after subtracting them from 1, uh, I am actually quite simply going to do, I might actually just do it in the same color. I'll say, okay, this larger area A minus this smaller area B is actually going to be my interval. We often refer to this as the negative interval, right? I'll just call this negative interval, and that is the same interval that we have right here. So subtracting smaller area from the bigger area, subtracting smaller area from the bigger area to get the central area, the interval area. But to get this interval area, you need to flip the negative z values to make them positive z values, so you can get these tail probabilities, which are in fact the same ones on the left hand side, and you subtract these areas to arrive at your final answer. Now try this on the z table, and you should arrive at the same answer that you arrived on Excel, which was 0.1759. Alright, I hope this makes sense. Let me know in comments if there are any questions.